All right, so we plugged in to our formulas here. Use this formula for x, use this formula for y. Use our knowledge of the unit circle. Cosine 3 pi over 4, that's second quadrant, so cosine is negative. That'd be negative root 2 over 2. But sine would be positive root 2 over 2. So this is going to be positive 3 root 2. And this is going to be negative 3 root 2. So 3 root 2, negative 3 root 2 is our point, x and y point, isn't it? How'd we do on that?
I was confused since it's 3 pi over 4, what that means.
Second quadrant is negative x, positive y. Isn't it? Yeah. Negative, positive. But remember, this is negative, so it flops it, doesn't it? So this would really be in the fourth quadrant, wouldn't it? Which would make x positive and y negative, so it fits. So if you think about it. Okay? All right, so now, what happens if we have a negative angle? What do we need to do? Change it to a positive by adding 2 pi, right? So what am I going to add to this? Thank you. So this is really negative 1/4 3 pi over 2, isn't it? So this says it is in the quadrantile that's down here, doesn't it? But since that r is negative, where is it really? It's really up here, isn't it? Which means that the x value should be what? 0. And the y value should be positive, right? So we know this is going to somehow end up with 0 something. Well, we can figure it out with the formula. That's going to be negative 1/4 cosine of 3 pi over 2. Negative 1/4 sine 3 pi over 2. So this is negative 1/4 times 0, which is 0. Check. And this is negative 1/4 sine of 3 pi over 2 is negative 1. So this is positive 1/4. That is a 0 for an x and a positive for a y, isn't it? That is on the first quadrantile. All right. What happens, though, if it's not on the unit circle, like, say, number 5? Use your calculator, but make sure it's in the correct mode. What mode does it need to be in? Degrees right now, doesn't it? That's the biggest mistake people make, is they forget to change their calculator mode. Get the right answer. So this is how we go from polar to rectangular. We use r cosine theta, r sine theta, just like we would have if we were doing vectors. So now, can you tell me, how do I go rectangular to polar? In other words, if I have an x, y, and I want an r and a theta, how do we do that with vectors? How did we get a magnitude and a directional? How do we get the magnitude? Square root of, instead of a squared plus b squared, what do we have here? X squared plus y squared. Yeah. Inverse tangent of over x. Again, analogous to vectors. So let's actually find one. And yes, you still need your unit circle out. Because if we get values that are on the unit circle for inverse tan, then you need to know what those are. So let's find r first. Square root of 2 squared plus 2 root 3 squared. 4 plus what?
12.
Thank you. Root 3 squared is 3 times 2 squared 4, so 12. So this is the square root of 16, which is 4. Now to find theta, we're going to do the inverse tangent of y over x, which is really the inverse tangent of root 3. Where is tangent root 3? Tangent is root 3 over 3, 1, root 3, pi over 3, and
4 pi over 3.
yes, thank you. Pi over 3, okay? So we're going to have the point 4 pi over 3. But 4 pi over 3 is also a point. But that, if we do 4 pi over 3, that's not going to land that point in the same place, is it? So I need it to be here. So what do I need to do to the 4 to make this point become that point? Put a negative in front of the r. Wouldn't that do it? Because for tangent, remember, the two values are going to be 180 degrees apart, aren't they? So all we have to do is throw a negative in front of the r, and it flips it back to where the other one was.
How do you know which one of them is based on?
Well, what quadrant is this? Quadrant 1. That's the one you base it off of. Whichever quadrant the actual point's in. So let's look at number 8. Let's do another one. What quadrant is this? So it's quadrant 4. So whatever angle we find that's our true angle that goes with our r is going to be in quadrant 4, isn't it? And then the other one will be in quadrant what this time? If we're looking for a quadrant 4 angle, down here, yep, 180 degrees will be the other angle, will be quadrant 2, won't it? And then we'll put a negative in front to take it back to quadrant 4. So r, 3 root 2 over 2 squared, negative 3 root 2 over 2 squared, (9) times 2 is 18 divided by 4. It's another 18 over 4, right? Which is what?
36.
Over 4, which is 9. So square root of 9 is 3. So r is 3. So now we got to find theta. Inverse tangent of what? Negative root 3 over 2? Or 3 root 2 over 2 divided by 3 root 2 over 2. So this is really the inverse tangent of what? Negative 1. So where is tangent negative 1 in the fourth quadrant?
7 pi over 4.
7 pi over 4. So we know one of the points is 3, 7 pi over 4. So what is 7 pi over 4's counterpart in the second quadrant? 3 pi over 4. Does everybody understand what we're doing with this? We know we've got an angle down here, a point down here in the fourth quadrant at 7 pi over 4. But if we go up to the same spire that goes across to the second quadrant, we can make the r negative, put the point there, but the negative then swaps it down 180 all the way back to here again, doesn't it? So this point, negative 3 pi over 4, really does end up down here on 3, 7 pi over 4. Okay? That's why there's 2. All right. So try an easy one on your own. Try number 10. What quadrant are we in this time?
2.
Okay. Yeah, I want the exact amount. Possible, please. For R at least, we want the exact amount. The only thing we would ever round to 2 decimal places would be the angle, and that's only if it's not on the unit circle. Right? So let's look at one where it's not on the unit circle. Does everybody understand why we used this 3 pi over 4 this time instead of the 7 pi over 4? What quadrant was this in? So we used the quadrant 2 angle this time. Even though it was exactly the same angles as this guy, we used the quadrant 2 one this time because of this. And then swapped the sign on the R and made the 4th quadrant one the alternate. Make sense? Okay. So let's do one more like this, and then we'll talk about how do we convert equations. That's a little bit trickier. Right now, we're just swapping coordinates, aren't we? So R is nothing because my pencil is suddenly run out of juice again. All right. Give it a sec, guys. Okay, so negative 2/3 is not on the unit circle. So I'm going to change this to degrees because, you know, degrees. Change my calculator to degrees. I get negative 33.69 degrees.
How do you convert to degrees?
You change your mode to degree mode.
Yeah, I got that. And then just put it in.
Yeah.
Okay.
So this is negative 33.69 degrees, but we don't leave it as negative, do we? So how do I change it to its proper? Add 360. So really what we have is theta is 326.31 degrees. So we've got 2 root 13, 326.31 degrees, and negative 2 root 13. How do I find the other one? 180, right? Because they're 180 off from each other. So subtract 180 from this guy to get this one right here, which would be 146.31 degrees. So there are my 2 points. Okay? How are we feeling about this? Pretty good? Pretty awful? You don't know? All right, so here we go. Converting rectangular to polar equations. This is equations now, not coordinates. Look what we have. We're going to use the same things we've been using. X equals r cosine theta and y equals r sine theta. So everywhere we have an x, we can put in r cosine, and everywhere we have a y, we can put in r sine. And then we solve. So we're going to sub in and solve for r. That's really the instructions. What do we sub in? Those guys. So x equals negative 3. X equals negative 3. So what is x equal to? R cosine theta equals negative 3. So now I need to solve for r. Yeah. Just divide both sides by cosine. This will have you flashing back to analytical trig because I don't want to leave cosine in the denominator, so how could I rewrite this?
Secant.
-3 secant theta. And that would be my equation. And we know that would graph as a line. It's there. You just got to scrape it back up out of your brain. All right, let's try another one that has an x and a y. What if it has an x and a y? What do we plug in for this y right here? R sine theta. And what do we plug in for x? Times √3/3. Well, the first thing I'm seeing is this. Do you know why I know that r has to go away? What equation does this represent? Y equals something times x. Come on, guys. What would a graph as? A line. It graphs as a line. And if you remember correctly, for it to graph as a line, it needs to be just in terms of theta, doesn't it? Oh, well, look at that. The r's dropped out. So this will be just in terms of theta, won't it? So how now do I get theta on one side by itself? Divide both sides by cosine. So now what do I get? Tan theta equals, how about that? But that's not good enough because that's not as just in terms of theta, is it? I got to get theta by itself. So how do I undo the tangent part? So theta is equal to the inverse tangent of √3/3. Where is tangent √3/3? And we don't care about the other part because the line's going to go through pi/6 and the other spire, isn't it? Won't the line go through this way? Ta-da! Okay, so you've got to have it either in terms of r or in terms of theta.
Will we keep it in the first quadrant?
No, this one will go all the way through.
I know, I meant for the
But-
pi/6.
Yeah. Think about it. You wouldn't have to do the other because it's going to go through that anyway. Yes, ma'am. I did inverse tangent. Inverse tangent to undo tangent. So this really is, if you look, you can see I did inverse tangent
No, I know, Lord. I'm saying, did you find the inverse tangent?
of √3/3 right here, yeah.
Okay, because I thought it was higher than 3. I have like the tangent.
It's, yeah, I think you got it wrong on your sheet because it starts at pi/6. Pi/6 is √3/3. Pi/4 is 1. Pi/3 is √3. It's getting bigger. And then it goes to undefined. Remember, you've got, if you look at the graph, it starts at 0 here and goes up. So it should be getting bigger as it goes around the unit circle, shouldn't it?
I have that, but I have those values for tangent.
Well, they are tangent. This is inverse tangent, not cotangent. You undo tangent by doing inverse tangent. Okay? Yeah, the reciprocal. You're thinking reciprocal. This is inverse. Now I see where you're at. Yes. Okay, not cotangent. All right. So what about y equals x squared? What do we plug in for y? This becomes r sine theta. And this x becomes what? R cosine theta, but it's squared. So this really becomes r sine theta, r squared, cosine squared theta. Just square everything, right? So now what's the first thing I can get rid of? One of the r's. So that goes away and this goes away. Now I need to solve for that r that's left, don't I? So r equals cosine squared theta divided by Sine theta, right? I could get r by itself.
Wouldn't it be sine theta over cosine?
Oh, sine theta, you're right. I did it backwards. Sine theta over cosine squared theta. Which we now need to fix. How can I fix that?
Would it be tangent times
Okay, so you're saying do this.
I split it? So maybe, I don't know.
Yeah, that's correct. Tangent theta, secant theta.
That's right.
Yes. Did it get everything out of the denominator? Then go you. Try number 4 on your own. This, instead of y equals x squared, we got x equals y squared over 5. It should sort of predict for you what's going to happen down here at the very end. Instead of tangent secant, what do you suppose you're going to end up with? Come on. If y equals x squared is tangent secant, then x equals y squared ought to be what? Cotangent cosecant. And then you got to figure out what happens to that 5. So just predicting that that's probably what's going to happen. See if you can work your way to that point and actually get that. Be careful and notice when you square up here, you do not square the 5. God, I hope they're done with those sharks after today. I don't think this hall's ever going to smell the same. I'm so sick of that smell. Y'all have no idea.
They're dissecting.
Yeah, they're dissecting baby sharks.
I have to stand up. Came up and was like, "Are you in trouble?" I think we're dissecting a rat. Was it a rat?
We did fetal pigs when I was in high
It
school.
was a rat. We had
Fetal pigs are rough because they kind of look like little babies. It's awful. At least a shark doesn't look anything at all like a human once the skin's off at all. It was pretty grim. I just invested in a can of Vicks salve and left it in my locker so that when it was dissection day, don't smell it. You know, that's what coroners do. Coroners put Vicks under their noses because it's really strong. It'll kill your smell. Well, now you know. All right. Anybody have any questions about number 4? Do I need to work it through? Yeah, multiply the 5 over to the other side and then divide out. Yep. All right. So look at number 5, guys. Look at number 5. What is this the equation of? Thank you. First block, they just sat there and stared at me. Till somebody finally, I think Amelia finally said, "Is that a circle?" I was like, "Yes, thank you. I love you." Circle. It's a circle that has a radius of what? 4. So if this is a circle, what should the equation end up looking like if it's a circle with a radius of 4?
R equals 4.
Thank you. R equals 4. You go. So we're pretty sure this is going to end up looking like R equals 4. Let's see how we get there. X squared is what? This is going to be R. So this is going to be R squared cosine squared plus R squared sine squared equals 16. Can anybody see why it's going to end up being r equals 4 yet?
Cosine squared plus sine.
So what do I need to do? Using proper mathematical language, what is my next step? You can't split it. Y'all know where it needs to go. Thank you. Factor out a what? Thank you. I'm going to make mathematicians out of you guys yet. And cosine squared plus sine squared is 1. So this is just r squared equals 16. So r equals 4. Woo! Look at that. Now, will number 6 do that? You know what the answer to that question is? No. Because it's not x squared plus y squared, is it? It's going to end up being what? Yep. So r squared cosine squared theta here. R squared sine squared theta here plus 1. I will tell you what I am going to do. We got to get this in terms of r, don't we? So what is the next move?
You could just cancel out the 1.
No. How?
Because the plus 1.
Yeah. Good. Move the r terms to one side. So r squared, and this becomes cosine squared minus, doesn't it? Oh, hey. Anybody had their sheet out that has all those Pythagorean formulas on it? The identities? What is cosine squared minus sine squared?
Cosine 2 theta.
Thank you. So this is r squared cosine 2 theta equals 1. So now what? Divide it both sides by cosine 2 theta. So now we have r squared equals 1 over cosine 2 theta, which is what? Okay. We can actually leave it this way, because it is still in terms of r, isn't it? R's on one side, theta's on the other. All right. They just get more complicated. This is rectangular to polar.
It's 11:30.
It's 11:13. All right. We will finish up after lunch. And we will be done with the last lesson. Guys, this is the last lesson of the year. It is. You have survived pre-cal.
The last time.
That's true. Good grief. So far, the last test is going to be on parametric equations, which are not hard.
Man, that was so rough.
Complex equations, right? Like complex
I can do
stuff.
Yeah, I can do that.
Swapping back and forth between parametric or between complex and polar, right? Or polar and rectangular. I mean, nothing we've done for the last couple days has been all that hard, has
The
it?
parametric
equation.
equation.
Graphing?
I'm not gonna lie.
Yeah,
That one kind of.
Wait, what was the parametric equation?
Oh, those things.
Oh, the
those.
two. I didn't like those. Oh, solving
Graphing them
were
was
easy.
easy.
Yeah.
The solving part was just.
And the restrictions.
Oh, the restriction one. You know, you solve it, you're just like, done. And then
It's not multiple
restrictions.
choice, you just say B anyway.
Time to hold my breath in for a while.
That's
That's what I was thinking.
You step outside and go.
Yeah, hold your breath and jog.
That's when I
Get out of this
decided to
hallway.
Not deal with animals.
Yes. Let's finish this up. All right, so what exactly, let's talk about the last little thing, which is converting from polar to rectangular. We went from rectangular to polar. Now we've got to go back. So what you've got to look at is the following. You've got 4 possibilities here. You've got r cosine theta is x, r sine theta is y, x squared plus y squared equals r squared, and tangent is y over x. So any of those can be substituted in because we're trying to get out of r and theta and into x and y only. So you've got to get rid of it. Now, this is going to be the hard part for most of you. The other way, it's just straight sub in and solve. This one, you actually have to use some brain power and reasoning to think about which one to use. Look at the first one, r equals 7. We know that's going to be a circle, right? There is nothing up here that's just in terms of r, is there? But there is, however, one that's in terms of r squared, isn't there? Yes? You also get the hint because you know r equals 7 is a circle. And we just saw one of those going the other direction, didn't we? It had an x squared and a y squared in it. Yes? Okay. So that should also give you a hint. So we're going to start by squaring both sides. So we get r squared equals 49. Now we can actually do the substitution. So what am I going to sub in for r squared? X squared plus y squared. And that is a rectangular form of this equation. And no, I'm not going to make you solve for y, even though I ought to. All right, well, what about theta? What do you know theta equals 2 pi over 3. What do you suppose that is going to be equal to? We said r equals was the circle. Theta equals was a what? It was a line, wasn't it? All right, so we don't have anything that's just in terms of theta with the exception of 1. Look at this guy right here. This one is the only one that doesn't have an r in it. That should give you a hint as to which one we should be using for this problem. So how do I get tangent theta equals y over x? So I can sub in y over x. I've got theta equals 2 pi over 3. So what do I need to apply to both sides? Tangent. I need to take the tangent of theta here, which means I need to take the tangent of 2 pi over 3. Now, what is the tangent of 2 pi over 3? Okay, so this is negative root 3, and I can sub in now for tangent theta. What am I going to sub in for tangent theta? Y over x. And since this is the equation of a line, I can go ahead and move this over, can't I? And say y equals negative root 3 times x. And sure enough, that's the equation of a line, isn't it? Now, let's look at this. It has r and theta in it. The fact that it has r and theta in it kind of should give us an idea of what we need to do here. I don't have anything with secant in it, so I'm going to start by changing this to what? Okay. So now, do you notice something? What could happen to this? It could go over there, couldn't it? This I do have. What is r cosine theta equal to? So now I can sub in. So why don't you try number 12, since it's analogous to it? Well, that's in terms of x and y, isn't it? That's rectangular. If you take all the r's and thetas and get x's and y's in there instead, as long as the r's and thetas are gone, you're done. So see if you can follow the same idea and get number 12. Get it? All right, the only reason we could do it that way was because sine was in the denominator, right? We could cross multiply it. What if it's not in the denominator, like number 13? We can't do the same trick here, can we? So what we have is r equals 2 sine theta. Well, I'm going to do another trick to help me figure out how to fix this, because I don't have an r, but what do I have up here? R squared. And if I square that side, now I'm not going to square it though, I'm going to multiply both sides by what? Why can I do that? Because now if I multiply by r on this side, and then I multiply by r on this side, what else do I notice? What else do I have here?
You have sine.
R sine theta. So I can kind of trick it into being what I need it to be. So now this becomes r squared, and this is 2 times r sine theta. So what is r squared equal to? X squared plus y squared. And what is r sine theta?
X. Y.
So now I want to turn this into something I know what it is. So I'm going to move this over. X squared plus y squared minus 2y equals 0. And I'm almost there. Not factor, complete the square. Because now I can tell what it's going to be. This thing is going to be a circle. Yeah, it is. It's going to be a type of circle, which, guys, we knew it was. Look, r equals 2 sine theta. Didn't we notice that this is going to be a circle? And it's not going to be, its center is not going to be, it's going to have a radius of 1, right? Which means its center should be up from that. Doesn't that make sense in what's going to develop here? Think about it. Half of negative 2 is what? Negative 1. Square that, you get 1. So we have x squared plus y squared minus 2y plus 1 equals 0. So this is x squared plus y minus 1 squared equals 0. Oh, 1. I don't know why I'm saying 0. Thank you. 1, 1, 1. Yeah. Well, this is 0. This is 1. This is 1. Yes. All right. So this thing has a diameter of 2, which means it has a radius of 1. And if it had a diameter, if I were to graph this guy, think about it, guys, on the polar coordinate plane, at 0, it would be up at 2, wouldn't it? Which puts the center right here. We know it would do something like this, don't we? Isn't that the picture we got when we were graphing them? Y is up. So the center is actually at 0, 1. And look, the center is at 0, 1 here, isn't it? So you can predict what the equation should look like. Why don't you guys try this with r negative 6 cosine theta? Again, we know what this should be. What shape should this be? Guys, we graphed this, a circle, but instead of being up, it's going to be where? Not to the right, because there's a negative in front. It's going to be to the left. It's going to be over here, isn't it? So we know the center is going to be offset, but it's still going to have a circle. And what's the radius of this circle going to be? Whatever half of this is, so 3. So we know it's got a radius of 3. So this thing should be equal to what at the end here? No, r squared, 9. So we know we're going to end up with equaling something 9. And since I know it's left 3, I can predict what this is going to look like. Because the center is going to be at negative 3, 0, isn't it? And a radius of 3. And now you got to work your way over to that point. Multiply both sides by r. So r squared equals negative 6 r cosine theta. So x squared plus y squared equals negative 6x. So x squared plus 6x plus y squared equals 0. We're going to add 9, add 9. This becomes x plus 3 quantity squared plus y squared equals 9. Sure enough. Ta-da! All right. Polar form of complex numbers. Guys, what is the polar form of a complex number? I want you to think about this. The A is like X, isn't it? And the Y is like Y, or the B is like the Y. Well, we know what that is then. I want you to think about this. R cosine is X, R sine is Y, isn't it? So think of A plus BI as kind of being X plus YI, right? Where X is R cosine and Y is R sine, isn't it? So write each complex number in polar form and then graph. So how do I write this in polar form? How do I get my R and how do I get my theta? Shows us right here. We know how to get R and theta, don't we? R is going to be equal to the square root of 4 plus negative 4 squared. So that's what? 4 squared, 32? Root 32? Yes? 16 and 16, so square root of 32, which is what? 4 root 2. Okay. And theta is equal to the inverse tangent of what? We better think about what quadrant it's in, though. 4, negative 4 is going to be in quadrant 4, isn't it? Would you agree? All right. So this is going to be the inverse tangent of negative 1 in quadrant 4 would be what? So this is going to be 4 root 2. 7 pi over 4, isn't it? So let's find that. 7 pi over 4. 4 root 2 is what? Just about 6. $5.6? About 5.6. So we're going to go over to 7 pi over 4, which is this guy right here, isn't it? And we're going to go out 1, 2, 3, 4, 5.6 will be right about here. And there's my point graphed.
It's in increments of 4.
Oh, is it? Oh, God. I can't even see. That's so small. All right, here. Ah, sure enough it is, isn't it? I'm glad your guys work. All right, so 5.6. So 2, 4, 5.6 should be about here then. That look better? Here, we'll put it here. And then I could erase the rest of this. All right? So now, let's try why don't you guys try one? What quadrant? So quadrant 2. See if you can find R. See if you can find theta. Get it? What do you think? Are we okay with this? All right, so let's do the last little chunk. Convert from polar form to rectangular. Guys, this is even easier. How do we convert from polar to rectangular? R cosine theta, R sine theta, but we got to make sure we're in the right quadrant, right? And guys, we know what R is. R theta. Right? So if it's 3 pi over 4, what quadrant is this? So quadrant 2, so it should be negative positive, shouldn't it? So x is 8 cosine 3 pi over 4. Y is 8 sine 3 pi over 4. What is the cosine of 3 pi over 4? Negative root 2 over 2. And the sine is positive root 2 over 2. So this is negative 4 root 2. This is positive 4 root 2. So this is the point, negative 4 root 2, 4 root 2. Why don't you guys try one? Or are we almost out of time? Okay. Well, guys, this is it. We're done. All things polar, we're finished. And you're good to go. Last homework assignments, except for review. Next time we will review. So Thursday we will review. Anybody not going to be here on Thursday? Do you need your review? If you'd like to go ahead and get your review, that's fine. So you can work on it over the weekend. Yeah, I know you won't be here.
You want to finish up the end of homework 1?
Yes, please, and finish at the end of homework 1. Anybody else? Okay. So your test will be
No, that's no.
it's awful. Baby shark, do, 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 do. If anybody missed last time and doesn't have this, they have to get it. You've got homework 4, homework 5 done. Homework 4 done, get homework 5 to do.